Hello students, welcome to SAM classes. Today we'll be doing the chapter dual nature, and if time permits, along with that we'll be covering up atoms and nuclei. Okay, or we can have a two video session, one covering dual nature and the other covering atoms and nuclei. So let's start the chapter. Dual nature. In dual nature, we just don't have division and Jarmer experiment. Atoms, everything is there. Now, nuclei, a lot of part has been deleted from radioactivity, alpha, beta, gamma decay, the radioactive law, decay law, half-life, mean life, binding energy per nucleon, and its variation with mass number. So a lot of these is deleted. So very less questions are coming up from the nuclei part. Dual nature and atom is getting the max attention in the question paper. So we can expect a more number of questions from dual nature and atoms. Okay, and from the nuclei part, what are the important parts? Then the nuclear force, the nuclear energy, properties and all, that part becomes a bit more important. Okay, so do focus on that. Let's start the chapter. If you have any doubt, put it on the comment section. And students, a very important notice for you all. Okay, a very important information. Okay, and what is that information is? Tomorrow we are conducting a mock test. Time and everything will come in a shorts video. Do tell it to all of your friends so that more number of people they can come and join and they can write the test and will be able to judge you all, will be able to understand where and what is the difficulty, and will schedule one-on-one call for all of the students to figure out whatever the difficult portion is and how we can enhance your performance whatever time we have left in that only. Okay, so do inform all your friends. Now where we'll be writing in the website onlinesamclasses.in. Okay, onlinesamclasses.in. Do join the WhatsApp group or the Telegram. Will be sharing a PDF where you will have the detailed discussion or the detailed step-by-step procedure how you can join the website and you can attempt the COMEDK mock test. The mock test, we have made it entirely on the basis of the previous year's questions so that it becomes more effective for you all and you are able to assess your performance, your what do you say current rank, and you're able to what do you say get an idea or an analysis of the chapters on the topics in which you are strong and the topics in which you are weak. Okay, so this is just for that. Don't take it like in a different way that I got less means I'll perform bad in that. No, we have 2 to 3 days, and the mock test is all about correcting and enhancing for the main test. Correct. It's not about to perform in tomorrow, but it's all about to know how you can perform well in the final COMEDK exam. Okay, so do inform all your friends. Do like, share, and subscribe to the channel. Okay, we are trying to bring counseling sessions, videos for your gates, MTech, and a lot of other things, experiments, different kind of passion which you can take. So that all will come after the exam session. Okay. So as of now, for the COMEDK, we do request all the students to share it with all their friends so that they can come and write the mock and they can have a one-on-one call session with us and we can explain him where is the loopholes where he can correct it and enhance its marks a bit more. Okay, so that is our sincere and best efforts from our side. From your side, you need to share this knowledge, you need to share this information to all of your friends so that they can come and write and we can have a very successful mock. Okay, so because the more number of students they're writing, the more better we'll be able to analyze the result and the more better we'll be able to explain them what are the loopholes. Okay, so very important update. Do check it. By evening we'll update in the website, in a YouTube short, or in the Instagram. You can follow us, its link is in the description below. You can join our WhatsApp group and the Telegram, and you'll be able to get the PDF of the detailed instruction how to write and how to attempt the mock. Okay, so that's it. Let's start the chapter. Now let's see in this chapter the first question that we have. An electron in a hydrogen atom is revolving around the positively charged nucleus. The two physical quantities which explains the orbit of an electron. Okay. Now if you remember a bit about the Bohr's model. If you remember a bit about the Bohr's model, what are the first two postulates, sir? Bohr's model. So the first postulate said that the total energy of an electron, total energy of an electron in a Bohr's orbit is what? Orbit is fixed. Means the electron does not radiate energy. Okay, means the energy that it is carrying in that orbit is what? Same, it doesn't changes, correct? So that only was the loophole in the Rutherford, and that only Bohr said that the total energy or the energy of the electron with which it is revolving around the orbit is remain same, and these orbits are known as stationary states, correct? Second, what he said is that only those orbits are permitted, only those orbits are permitted in which the angular momentum is integral multiple of h by 2 pi. So he said that the angular momentum of a electron in an orbit is what? Quantized. So it means what? The angular momentum and total energy of an electron, correct? So, so what is the question here? Again, understand an electron in the hydrogen atom is revolving around a positively charged nucleus. So two physical quantities which explains the orbit. First thing is the angular momentum. It is explaining that the orbit is having a quantized angular momentum. And second thing is, what is it telling? The electron in an orbit, the total energy of the electron in an orbit remains same. So these 2 points, the two postulates of the Bohr's, the first two postulates of the Bohr's model are very important. That only they have asked here. Nothing more than that. Okay. So don't get confused. A very simple question they have asked. Okay. Now let's see. Let's see the next question. So in the next question, we have a graph, kinetic energy versus frequency. Okay. Now, before understanding this graph, let us understand a story. A very small story. If you understand this story, you'll be able to solve everything. Okay. Let's understand the story. So what happened is, one day you made a plan to go with your friends on an outing. Correct? So what happened? Your bunch of friends with all energy they came, okay? With all the energy they came to your home. Correct? This is your home, you're sitting, and they came to your home with a lot of energy and enthusiasm. Okay? This is all your friends, okay? They came with a lot of energy to your home, and this is you. Correct? So they came. Now, the moment they came, they told your parents that we are going out for an outing or a picnic or like to spend some chill time, okay, whatever you call it as. Okay, so your parents said no, exam time is near. They gave millions of reasons. He's not studying properly. What if he goes now and something happens? What if you're not like, what do you say, his tuition is left or something, he has something this, he is not feeling that well and all. So the parents, they what they did, they tried to stop you all, correct? So a lot of the energy got spent in this part, a lot of the energy, this is the parents. So they explain no, you should not go, okay, you should stay at home, he won't be able to go, he won't be able to join you all. Okay, you were explaining them, see, it is very important life part of your career, your friends again can come, okay, you can again go for an outing, but this is the exam time, you can't do anything. So they explained a lot, okay, you should study more, but you said no, I want to go. Correct. So whatever, after nagging from your parents, after convincing them, no, I'll come back and I'll study more. Okay, I'll be more focused in the study and I'll do more better. Okay, so you explain them in a very different ways. Though your energy was going down, but still you were able to manage to explain them, and you were able to come out of the house. With what energy? This energy. Okay, with this much of energy, you were able to come out of the house, and this much energy was left with you. Okay, so this is the picture for a electron also. So what happens? Your friends are nothing but bunch of photons. Okay, your friends are nothing but bunch of photons which they are coming to your house, basically to the metal is the house. Okay, this metal sheet is the house. Okay, and they're explaining to you the electron, they're giving the photon is coming, and they're what, hitting the electrons, and they're imparting the energy, they're transferring the energy. The electrons, after taking the energy, what happens? It wants to go out, but before going out, the metal is holding that electron, correct? So you know it has to overcome that barrier. So it has to spend some energy in that. So a part of the energy is spent in the work function of the metal. It is spent in the work function, correct? This is known as the energy spent in the overcoming the barrier with the metal is known as the work function. And whatever the left energy that you're coming out, that is the kinetic energy or maximum kinetic energy of the electron. That you can either express in the form of half mv square, or you can express in the form of ev, electron volt. Okay, so very simple story. Your bunch of friends came, they explained you, we want to go out, have chill, have a party. Okay, so your parents restricted, the metal here is restricting. Okay, with the barrier you overcame them, like, but you spent a lot of energy in that. That is your work function. And whatever the left energy you came out, so that is your kinetic energy max. So from here, what is the equation we got? H nu, the total energy, is equal to the energy spent, H nu naught, and that is also equal to phi naught, same thing, work function, plus kinetic energy. So you can understand like this is, you can understand this as, this is the energy with the of the photon, energy of the photon when it came and hit the electron. That energy is used to do two things. One, to overcome the barrier, to overcome the barrier or the bond. Okay, and next, whatever is the left energy after breaking up the bond with the metal or the atom, whatever the left was, that came with you as a kinetic energy. So that is the whole story. Now we want to plot a graph between what and what? Kinetic energy. So what you can write? K max is equal to what? The total energy that is of the photon, h nu, minus the energy that you spent on what? Overcoming the bond, h nu naught. So K max, this can also be written as ev naught, same thing, is equal to h, I can take common, nu minus nu naught. Correct. So what I can see is, what I can see that a part of my energy, see the moment, what do you say, and a photon comes, a part of my energy will be spent in overcoming the barrier. And then after that, what happens, once I cross this threshold frequency, the minimum energy that is required to come out of the metal, I'll be, the more frequency it is, the more electrons will be able to come out faster. Correct. The more, with more energy, it will be able to come. So what we can see, that kinetic energy max is directly proportional to frequency. Okay, but it should cross a minimum value. See, until unless you are able to convince your parents, you are not able to come out. So the kinetic energy, so that's why there, see, there is no emission in this. Okay, so let me just expand this graph, understand. See, till this frequency range there was no emission. Till this frequency range the electron was not able to come out. Why? Because you are not in this range, you are not able to overcome that barrier. The moment you overcome that barrier, you're able to convince your parents, no, from tomorrow onwards you will study. You're able to come out, and the more energy, with more energy your friends came, the more energy you'll have to go out with them. Okay, so that's a simple story, keep that in mind. You'll be able to do most of the questions. Okay, so let's see the next part. So answer to this is this one. Do put in the comment section, did you like this story? Okay, and if you don't like it, that also you write it down, no problem, be honest. Always I appreciate your honesty. Okay, now photoelectrons will be emitted from a material of threshold wavelength 5200 angstrom. Then what is an angstrom? So 10 power minus 10, correct, meter, 10 power minus 10. The incident monochromatic source should be, now what it should be. So here the question looks like very critical, correct? No, nothing critical. Just now what equation I told, for all these equations, this is the Einstein's equation, and each and every question you can solve by these equations, almost all of them. So kinetic energy is equal to h nu, the total energy of the photon, minus, always whenever you are saying, do say it like this, so you'll be able to have a very good clarity. Okay, see, this is the total energy of the photon minus the energy that I'm spending what, in overcoming the bond, correct? So now this I can remember, if you remember, c is equal to what, sir? Nu lambda. The speed of light is equal to what? Frequency into wavelength, frequency into wavelength, correct? So I can write frequency is equal to what? C by lambda minus hc by lambda naught, because see, I need it in terms of lambda. So what I got, kinetic energy is equal to, now in order for an electron to come out, kinetic energy has to be what? Greater than 0, positive, then only it will come out. No, if it is 0, means it is just on the boundary, it is not able to come out. If it is more than 0, it will be able to come out correct. So this hc by lambda minus hc by lambda naught will be what? Greater than 0. Correct. This whole thing represents what? Kinetic energy of the electron, and that has to be positive. Correct. So hc constant, so remove it. So 1 by lambda minus 1 by lambda naught is greater than 0. So 1 by lambda minus 1 by lambda naught is greater than 0. So what I can say, I can send it that side. So 1 by lambda is greater than 1 by lambda naught. So I can say lambda naught has to be greater than lambda. Correct. So lambda naught has to be greater than what? Lambda. So what we can see from here is that what is the minimum threshold frequency? 5200 angstrom. If I convert it, I can get it like lambda should be less than what? 520 nanometer if I want. Now why I wrote in nanometer? Because when you will read EM waves, I have most of them in terms of nanometer. Okay. So I know UV light lies, the lambda of UV is like what? For a UV, okay, ultraviolet, the lambda is less than 400 nanometer. So any light which has what you say wavelength less than 520 nanometer will be able to bring it out. So UV has that, so it will be easily able to bring it out. Clear? So we just needed to solve it that kinetic energy has to be greater than 0. The moment kinetic energy is greater than 0, so what is the condition of lambda? That our lambda should be less than the threshold lambda. Okay, so our threshold lambda we got 520 nanometer. So our lambda should be less than that. And for that UV light has lambda somewhere around 400 nanometer. So that will be able to bring it out. Clear everyone? Let's see the next question. Now we have a particle of mass m at rest. So make a particle. This is mass m and rest. So velocity equal to 0. Now what happened? This broke or decayed in two part, m1 having v1 velocity and m2 having v2 velocity. Okay, so now here a lot of people will say, sir, this is about decay, but this is since they have given about de Broglie wavelength, so we have taken this question. Okay, so here what I can say, I can conserve the momentum. So initial momentum is what? M into v, mass into velocity, and that is equal to final momentum m1 v1 plus m2 v2. Correct. Momentum is what? Mass into velocity. Everybody knows the formula. Correct. So this momentum, since the velocity is 0, since it is at rest, so this is 0. So that is equal to m1 v1 plus m2 v2. So what I can write is m1 v1 is equal to minus of m2 v2. So I can say that the magnitude of momentum for the first one is equal to magnitude of momentum of the second one. Now we know lambda is equal to h by p. Lambda is equal to what? This formula I'll give you, one page formula I'm giving you all. I think so you'll like this concept. One page formula, and every formula is written in that one page. Okay, so it will be helpful for your revision. So lambda is equal to h by p. So that is equal to h by p1 for lambda 1. So let's say write down lambda, wait, okay. So lambda 1 by lambda 2 is equal to h by p1 into h by p2. So cut, all cut. So 1 is to 1. Correct. So very simple question. I don't think so anybody will have doubt in this. Correct. Now let's see the next question. Now the next question what we have is, if particles are moving with same velocity, then what is the which has the maximum de Broglie wavelength? Okay. Now see, in almost all of these questions are directly formula based, students. Again, so formulas are very important. So right now we wrote one formula which what gives a relation between lambda and momentum. So lambda is equal to h by p. Yes, sir, we wrote this one. Everybody said lambda is equal to h by p. Okay. While doing, do keep a pen and a paper and solve with me. You'll be able to solve all the questions. Okay. So what is momentum, sir? Sir, mass into velocity, correct? So if they have the same velocity, so I can cancel the velocity part. Velocity becomes constant. H is also constant, so I can say my wavelength is directly proportional to 1 by mass. Correct. Can I say all? Anybody has any doubt? My wavelength is directly proportional to mass. Now understand, students, what is given here. I have been given 4 particles: neutron, alpha, beta, proton. Okay. So I know mass of alpha particle is more than mass of neutron, and neutron is almost near to proton, but actually a bit more it is. Okay, very small, but it is. And proton is way much bigger than that of electron. You should know this. So let's say mass of proton, if I say almost neutron, is almost greater than mass of proton, and mass of proton is somewhere around 1836 times of mass of electron, means way bigger. And mass of alpha particles is 2 times of 4 times of mass of proton, correct? So see, so alpha is the most dominating. So what will happen? Lambda of electron, since it is the smallest mass and it is inversely proportional, more mass means less of lambda. Again, everybody said inverse relation, more mass means less of lambda. So lambda of electron will be what? And beta particle is what? Just electron. So you should know a bit. So then, so the electrons will have the maximum. Okay. So the de Broglie wavelength of the beta particle, that is electron, is the highest. Okay, everyone. Now let's see the next question. Very simple. Again, similar to that. Comparing the de Broglie wavelength of electron, alpha particle, proton, having the same kinetic energy. Okay. So they gave what? The twist is having same kinetic energy. So let's find a formula. Sir, we already know lambda is equal to h by mv, correct? Lambda is equal to h by p, that is equal to h by mv. Sir, we already also have a formula, sir. Momentum is equal to, sir, root under of 2 into mass into kinetic energy. What is momentum? Root under of 2 into mass into kinetic energy. I can write h by root under of 2m kinetic energy, correct? So my kinetic energy is the same. What they said? They have same kinetic energy. Remove it. They have same h. So 2 is constant. So what is inversely proportional to root of mass here? So lambda is inversely proportional to root of mass again. So now you know mass of alpha. So this is very similar question, correct? Is more than mass of proton, is more than mass of electron. So alpha, sorry, alpha, why I'm telling lambda, sorry students, lambda is equal to h by mv. If I said alpha, do can't change it. Lambda is equal to wavelength, lambda is equal to h by mv, and that is equal to h by root under of 2 into mass into kinetic energy. I think so. Back also I've said. So put it, make it lambda, it's wavelength. So lambda is directly proportional to 1 by root m. So more the mass, less the lambda. Okay, less the wavelength. So wavelength of electron will be more than the wavelength of proton, and then it will be more than the wavelength of alpha particles. The answer is D. Everybody got it? The answer is D. Very simple question. Okay. Now let's see, all is like similar formulas. I'll give you the formula sheet. So you'll be able to mug it up, keep it on your fingertips. You'll be able to solve each and every question in like just seconds, okay? Alpha particle has de Broglie wavelength lambda. So let's say we have an alpha particle. So its wavelength is what? Lambda. Now, which is accelerated through a potential difference of V volt. So understand, okay. So what happens? Alpha particle is there, you accelerate it through a potential of V volt. To have the same wavelength, a proton should be accelerated to a potential difference of what? Means what they're trying to say is that the wavelength of proton is equal to the wavelength of alpha particle. This they have given. Correct. That only they're asking. No, in order for the proton and the alpha particle to have the same wavelength, what should be the value of voltage? Correct. Clear, huh? Okay, everyone. So what is the formula? Okay, sir. Sir, we don't know any formula regarding that, sir. We know. What is the formula? Lambda is equal to, we know, see, everybody say it with me. Lambda is equal to h by p. So lambda is equal to h by mv, and that is equal to h by p. So, and we know momentum we can write in terms of kinetic energy. So 2m into kinetic energy. And we know kinetic energy can also be written in terms of electron volt. So 2m into charge into voltage. Okay, because kinetic energy is same as if you take a charged particle and accelerate it with a voltage V, the amount of kinetic energy that you will get will be same as EV. So kinetic energy is equal to QV here, students. Very, 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 very important. Okay. So what we got? So we got 2m charge into voltage, 2m charge into voltage. Now lambda for the proton part is equal to lambda for the alpha particle. So lambda for the proton will be what? H by root under of 2 into mass of proton into charge of proton into voltage of proton, correct? And that is equal to h by root under of 2 into mass of alpha particle, charge of alpha into voltage of alpha. Now you'll say, sir, so many values you have given. Okay, becoming very, very difficult. Nothing is there. See, mass of alpha particle is equal to what? 4 times mass of proton. Very good. Charge of alpha particle is equal to what? 2 times of charge of proton. Correct. So let's write it down, open it up. Okay. So we can just remove root. Okay. 2. So what you can write? Mass of proton into charge of proton into voltage of proton is equal to mass of alpha, charge of alpha, voltage of alpha. Correct. So what I can write? Mass of proton, this all you don't have to, I'm writing a lot of times, okay, so that you understand it better. You can do it directly, okay. All these formulas directly you can write one line and then solve it, okay. So mass of alpha particle is what? 4 times the mass of proton. Charge of alpha 2 times the mass of charge of proton and to V alpha. So this and this got cancelled, this and this got cancelled. So it should be 8 volt. Correct. It should be 8 volt. That's it. Clear everyone? So everyone got it? Very simple. Okay. Now, next, the experiments of Frank Hertz based on Bohr's atomic model. We'll come to that part later. Let's see the one-page formula. Every formula, whichever is important, is written here for you all so that you all understand and you can do it better. See, kinetic energy of an electron can also be written as half mv square, which we know from long term, correct? And that can also be represented as charge into with the voltage with which you have accelerated it, that is EV. If you have accelerated with QV, means charge is Q and the voltage is V. For an electron, it is EV. For any other particle, it is QV. Clear? Don't get confused in that. Now, this one already I told you the story. Okay, your pack of friends means your photon buddies, they came, they hit you, and they told you, okay, buddy, we need to go out. But in order to go out, you need to convince your parents, means you need to spend a bit of your energy on the work function, means you need to say to the metal that I want to go out. And after what is spending that much of energy, whatever energy is left, you're coming out, and that is your kinetic energy. So phi naught is work function, and that is also equal to what is it, h nu naught. So the total energy of the photon is equal to h nu, that is equal to, it is used in two things in overcoming the barrier, plus whatever is left is given as kinetic energy. That's it. So from here we get k max is equal to the energy of the photon minus the barrier, energy spent on barrier. So h nu minus h nu naught. This can also be written as hc by lambda minus hc by lambda naught. Correct, everybody? Got it? 1 electron volt is equal to how much, students? 1 electron volt is nothing but 1.6 into 10 power minus 19 joule. Okay? Directly the charge, you can write it of electron into joule. That is the 1 electron volt in terms of joule, the energy. Okay? Now, we know energy of photon is equal to h nu. Can also be written as hc by lambda. And that is also equal to mc square. Everybody knows that, correct? Momentum is equal to, that way I can write h nu by c, and that is equal to h by lambda. So from here directly we get lambda is equal to h by p. Okay, do write it, very simple. Now kinetic energy in terms of temperature also we can write k is equal to 3 by 2 kt. Here small k is Boltzmann constant. So lambda is equal to h by p. If sometimes they give you temperature and all that, you can use this formula. Root under of 3m kt, where k is small k and that is Boltzmann constant. Okay. So we already know lambda is equal to h by p, and that is also equal to h by mv. Okay. Now next we know kinetic energy is equal to what? If I solve it, that is also equal to momentum square by 2m. Momentum square by 2m. So from here we can get momentum is equal to root under of 2 times the mass into kinetic energy. Very simple and very useful formula. Very important. So lambda is equal to h by p. So that is also equal to what? H by root under of 2m into kinetic energy. Correct, we got it. So for any electron, I can write energy as half mv square. That can also be written as EV. Okay, so from here we can get volt. What is say? Velocity is equal to root under of, in terms of electron volt, 2 EV by m. Very simple. Okay. Here again we can write the lambda also in terms of. So momentum is equal to mv, and that is equal to root under of 2 EVM. Correct. So lambda of electron is equal to this value. You can mug it up. 1.227 by root v, means this is the voltage. Okay. And the last formula, lambda is equal to h by p, we already know that, and that is equal to h by root under of 2 MeV, electron volt. So this is, we are done with this part. Okay, so very simple questions were there of the chapter dual nature. Now, few one or two questions are there. More, let's see the part which we have. So the next question is, here we have, if lambda of electron, lambda of neutron, and lambda of alpha particle are the de Broglie wavelength of an electron, neutron, and alpha particle having same kinetic energy. Okay, this we have already done, students, correct? Yes or no? Let's see. Lambda is equal to what? Just now we wrote the formula, sir. H by root under of 2m into kinetic energy. Now they have kinetic energy same, H same, 2 same. So lambda is directly proportional to what? 1 by root m. So directly from here, we know mass of alpha particle is more than mass of neutron, is more than mass of electron. So lambda of electron should be more than lambda of neutron, and that should be more than lambda of alpha particle. Correct? So very simple. Okay. Next question is one graph. Okay. In a photoelectric experiment, the slope of a linear graph between stopping potential. Now, what is the term stopping potential? Okay. See, what happened is from this metal plate, the electron was coming out. And when you apply the positive plate here, the electron is running and coming. Just say you went out of party and some restaurant is giving, okay, bumper offer 50% off, 50% off on whatever you eat, correct? So you'll go running, correct? Okay. Now suddenly what it happened is parents didn't wanted you to go and they knew like which restaurant you are going. So that restaurant said everything is double the price today. So what will happen? You'll again go back like this much money we didn't pay, sir. Correct? So here when we apply a negative potential so strong that it is pushing the electron to come back to the metal again. So that potential is known as stopping potential. And that is equal to what? The energy which you are going. If I cancel out the energy with which you are going, you'll just stay at home, correct? Though again understand, very simple concept. Though your friend came with a lot of energy, means the photon came with a lot of energy, correct? But you spent a part of your energy convincing your parents, that is your work function, to come out of the metal. And after that, whatever energy you had, that became your kinetic energy. But if I apply a very strong potential here, electric field, which can make this energy equal to zero, okay, means which will be opposite, which will be same in magnitude but opposite in the direction, and it can cancel and make your kinetic energy zero. So again, just be staying here, correct? So that only for the electron means stopping potential, means the potential required to stop the electron. Though you overcome the metal, what do you say, the barrier of the atom, but you don't have any energy to go out. Whatever energy you had, your friends gave it to you, you spent all in explaining your parents. Okay. So our Einstein's equation, if I am writing wrong spelling, do correct me, students. Okay. Einstein's equation. So what is that? H nu means the energy of the photon is used in two things: overcoming the metal barrier, and then whatever is left is given as kinetic energy. That is also written as EV, stopping potential. So H nu is equal to H nu naught plus EV. So I can write H nu minus H nu naught is equal to EV. Correct. So if I write here H nu, H by E nu minus H by E nu naught is equal to potential V. Correct. So if I write, this is basically they're asking in terms of a graph between stopping potential, that is my V, and frequency. This is this one. So this is my y-axis. Okay. If any graph we make straight line, so y is equal to mx plus c. This is m. This is x because I have to make a graph with frequency, not stopping. What do you say? Threshold frequency plus c. So this is my what? This is my constant term or the intercept, and this is my slope. So what is my slope? H by E. What is my slope? H by E. That is ratio of Planck's constant to the charge of the electron. Ratio of Planck's constant to the charge of the electron. Okay. Now let's see the next part. If the kinetic energy of a free electron doubles, now suddenly bumper offer. What happens? Kinetic energy double, what will be the change in wavelength? See, all the questions are almost similar to this only. Like few formulas, if you mug it up, dual nature is like killed. So lambda, sir, we know h by p, that is equal to h by root under of 2m kinetic energy. Correct. Now what you said, sir, kinetic energy doubled. How can we double a kinetic energy, sir? Very easy, sir. What we need to do, in order to double a kinetic energy, in order to insert some value, I can see lambda is equal to remove all the other h by, I need to root under of 2m kinetic energy. I need to multiply this with 1 by root 2. Then only this root 2 will be inserted. So if I'm multiplying there, I'll multiply here also. So lambda by root 2 is equal to h by root under of 2m kinetic energy into 2. Correct. So means I need to multiply this whole thing with 1 by root 2 times. That's it. Clear? So very simple. Now again, if the momentum of a particle varies n times. So what they have given is, we know what is kinetic energy is equal to what? P square by 2m. Now, a lot of students, sir, how did we get this formula, sir, P square by 2m? Okay, let me show you. Kinetic energy is equal to what? Half mv square. Correct. Send to that side. So 2 times of kinetic energy is equal to what? Mv square. Now multiply with m both sides. Correct. So 2m into kinetic energy is equal to what? M square v square. So that is equal to what? Mv whole square. That is equal to what? Momentum square. Got it formula? So kinetic energy is equal to momentum square by 2m. So here what you can see is the mass is same of a particle. Okay. So kinetic energy is directly proportional to what? P square. And if you're increasing P to n times, so kinetic energy will be what? Directly proportional to n square also. Correct. So was it very difficult? Very simple questions, correct? One line is, if the mass of a body and E is the kinetic energy, then it's linear momentum. See, directly formula. Again, what is they have said? Kinetic energy is equal to, so P square by 2m. So kinetic energy they have written by E. Very good, no problem. Momentum you write by P square by 2m. So what will be P? E into 2m and then square root. That's it. So 2m. Was it very difficult? Correct. So very simple, no? So all these questions are very, 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 very simple. Let's see the next part. What is the momentum of a photon having frequency this much? So we need to find the momentum of a photon. So we know momentum is what? P is equal to h by lambda. We know lambda is equal to h by p. So P is equal to what? H by lambda. Now I already told you c is equal to speed of light is equal to what? Frequency of photon into lambda into the wavelength. So from here, can I find lambda is equal to 3? See, speed of light I know by 1.5 into 10 power 13. They've given the frequency. Correct. So from here, if I solve, I'll get 2 into 10 power minus 5. Now what about momentum, sir? Directly put momentum is equal to what? H value is what everybody knows, 6.26 into 10 power minus 34 divided by 2 into 10 power minus 5. Correct. Do we need to solve? So if I solve, I'll get 3.3. That is correct. 3.13, correct. That is around 3.3. And minus 34 plus 5 is what? Minus 29. So this should be the answer. That's it. Correct. So I'll get this 3.13 into 10 power. I can write it as 3 if I done. Clear everyone? So very simple questions are coming. Let's see one graph is there. The graph between kinetic energy and momentum. So it's just, sir, very difficult. Illa, nothing. Just remember the formula. What is kinetic energy and momentum relation? Momentum square was equal to 2 times of mass into kinetic energy. That's it. So this is what? If this is my x, so this is x square is equal to some value constant into y. So it is a parabolic graph, that I know, because x square is there, parabolic. Now what kind of parabola? Understand, whenever you used to have x square is equal to 4ay, so what happens? For two values of x, we used to get one value of y. Two values of x, one value of y, like this. Correct. Two values of x, one values of y. So same thing, two values of momentum will give you one value of what? Kinetic energy. So if I draw a line like this, two values of momentum will give me one value of kinetic energy. Okay, means plus one momentum and minus one momentum, both will give me, just imagine, what you say, some value, same value of kinetic energy, let's see. Clear? Because if I do momentum as 1 and square it, that also will give me same kinetic energy. And if I do momentum as minus 1 and square it, that also will give me same. So you can understand very logically that two values of momentum will give me one value of kinetic energy for one value. Correct? So see how easy the questions are. Okay. So one very good question. How many photons are emitted per second by a 5.1 mega milliwatt laser? Okay. What is not there? Laser source operating at 390 nanometer. So we know first energy of photon. Sir, energy is equal to what? What is energy? We need to find the energy. So energy is equal to what, sir? E is equal to hc by lambda. E is equal to hc by lambda. So I'll put the value 6.6 into 10 power minus 34 into 3 into 10 power 8 divided by 390 nanometer, what? 10 power minus 9. So everybody knows nanometer means 10 power minus 9 meter. Correct. So then I'll get somewhere around value 0.05 into 10 power minus 17 joule. Now, what is the energy emitted per second by laser? Energy by laser, that is equal to 5.1 into 10 power minus 3 joules, correct? Now, what is the number of photons? If I want to find number of photons, just divide it. Energy of total energy emitted by energy of one photon, correct? We used to do the same thing. No, you went to the market to buy 10 pens. What is the total cost of the 10 pen? Divide by the cost of one pen. You'll get the number of pens. Correct. So the number of photons equal to total energy 5.1 into 10 power minus 3 divided by 0.05 into 10 power minus 17. So somewhere 1 into 10 power 16 photons you'll get. Done. So was it very difficult? Very simple questions. Correct. So we have solved a lot of questions in such a small time. So if you practice, if you just revise it, you'll be able to solve all of them and you'll be doing great in exam. Okay. Don't worry, I'll try to put up everything as much as I can. I'll try. Okay. Tonight we'll bringing up maths also. Now, for a kinetic energy K of a photoelectrons, if the wavelength of the incident light is lambda, then the wavelength lambda for the kinetic energy of electrons to be 2K. Very simple equation. You don't have to. Same thing. If I want to double the kinetic energy, how much previously I multiplied? Sir, lambda is equal to, sir, h by root under of 2m into kinetic energy. In order to make kinetic energy double, sir, what you have done? You multiplied with 1 by root 2, sir. Correct? Yes, everybody correct in the chat section. If I multiply 1 by root 2 will go inside directly, sir. So it can be doubled. Correct? So here it can be, I can see that it can be doubled root under of what is a 2m kinetic energy into 2. So basically, we are multiplying lambda with 1 by root 2. Means if I take this as new lambda, so it becomes lambda by root 2. So if I'm dividing, means it becomes less than lambda. That's it. What is there in this difficulty? What is the difficulty here? Nothing is the difficulty, correct? So everybody is understanding the concepts. If I'm being fast, do slow it down and then watch it. If you have still doubts, do ask it, okay? And work hard for COMEDK. 2-3 days are there, okay? So if you work really hard, I'll be happy that whatever efforts we have done and you're able to put more efforts, you're able to do something good in COMEDK exam, that's more than enough, okay? Next, ultraviolet light of radiation, this much is there, okay? So means you have a metal plate. This is like the ultraviolet is nothing but your friends, correct? So they're coming and giving energy to the electron. So how much is the energy? Now here, one thing very important. Just now I told 1 electron volt value you should know. That is equal to in energy in joules form how much? 1.6 into 10 power minus 19 joules. That's much. Okay. So H nu here will be what? 6.2 electron volt. So convert it 1.6 into. Now a lot of students will multiply here. 6.2 into 1.6. Illa illa. Never multiply. Okay. Now phi, that is my work function, means the amount of energy that I'm spending to explain my parents, okay, that I want to go out. That is equal to 4.2 into 1.6 into 10 power minus 19, correct? Now we already know K max, maximum kinetic energy is equal to what? The energy that my friends brought and the energy I wasted on explaining to my parents, correct? So 6.2, I can take that minus 4.2, I can take that as a constant, like common. So 1.6 into 10 power minus 19. So what I got? 2 into 1.6, correct, that is equal to 3.2 into 10 power minus 19. That's it. 3.2 into 10 power minus 19, correct? So was it very difficult? See, just remember the thing and you'll be able to solve. So that's up for the dual nature. I think so you got the concept of the dual nature. Okay, so that's it. Work hard for the mock. We're releasing the YouTube shorts and on Instagram also will release a reel. Do check it. Join the WhatsApp group and the Telegram for the mock tomorrow. Work hard, give your best.